Out of all the topics I'm going to discuss in this class, this is probably the one that is not taught in even honors algebra or even honors pre-cal, except when we need it towards the end of the second semester. Just one of those topics that kind of gets shortchanged because it's just thrown in with a lot of other stuff, or we can't throw this in with, adding, subtracting rational expressions. So we call these complex rational expressions. Now, they're called complex because of the definition. Fractions are tough enough, but when you start putting fractions within fractions, or more generally, a rational expression within a rational expression, you get pretty complicated things. So I don't think that's why they call them complex, but the bottom line is you're never allowed to leave those as a final answer. I mean, think about this. This is a fraction. The whole thing is a fraction, and there's a fraction inside of that fraction. So this would be read as 5/8 tenths. 5/8 tenths. This one would be read as 3 2/3. It's very complicated to wrap our heads around that. So we never leave a fraction within a fraction. That's the idea. Now these two problems are pretty easily dealt with. We deal with them by simply thinking of this as, a division problem. Every complex fraction has what's called a major fraction bar. At least the ones that we're going to work with. The major fraction bar is the big fraction bar, right? If there's fractions within fractions, there's plenty of fraction bars, but this is the biggest one. So this divides numerator and denominator of the entire complex fraction. So the numerator of this complex fraction is 5/8, the denominator is 10. And to handle this is not as difficult as you might think. It's just a division problem written out vertically as opposed to horizontally. This is the same thing as saying the fraction 5/8, interpret your major fraction bar as a division. 5/8 divided by the denominator, 10. This is written out vertically. This is written out horizontally. Written out horizontally makes a whole lot more sense to us because it's just dividing two fractions. What's the big deal? Well, we handle this as 5/8. Division becomes multiplication, and we take the reciprocal. So it comes down to 5/8 times 1/10. Quick little pre-canceling here, or cross-canceling if you prefer. And nothing happened the other way. Looks like the final answer is 1/16. We can wrap our head around the fraction 1/16 as opposed to 5/8 tenths. True enough. Okay, second one. Same idea. Rewrite it out horizontally. This is 3, literally, major fraction bar. We'll interpret as this division symbol. Divided by 2/3. Again, we'll call this 3 times the reciprocal. So we're looking at nothing canceling. I guess this is, 9 halves. So when you say 3 2/3, wow, that's complicated. We're talking about 9 halves. It's the same fraction. Right? So fractions are bad enough without throwing fractions within fractions, but if they ever occur, you have to be able to deal with them. Right? Now, these were very basic ones. You can see over here, ooh, we got some rough ones. Now, one way we can do this, and this is not the way I'm going to show, but one way we can do this is actually, let's take 3/4 and subtract 2/3. Get one fraction. Take 5/6 and add 1/12. Get one fraction, and then we'll do the division thing. We can do it that way, and I just said I'm not going to show that. You know what? I think it's worth showing. We're going to subtract these two fractions. Unfortunately, we need common denominators, so we'll go with 12. Let's see. 3/4 is 9/12 minus 2/3 is what 12? That would be 8/12. So the numerator is 9/12 minus 8/12. The denominator, also common denominator, looks like it's 12 in both cases. That would be 10/12, and that would be, 12/12. So in the numerator, we would have 9 minus 8 is 1/12. In the denominator, we have 10 plus 12 is 22/12. And now you can see you have a complex fraction. I mean, we had one before, but instead of 4 fractions within one fraction, it's just 2 within one. Here's your major fraction bar. So we have 1/12, literally divided by 22/12, which will be 1/12 times 12/22, The 12s cancel. We get 1 over 22. Now, we could definitely handle that problem this way I just showed you, but this is a very, very painful way to handle a complex fraction. And when you get to problems like this where there's variables, this is definitely not the method you want to go by. I mean, it works, but it's not the fastest method. There's a much cleaner, much quicker method for handling these complex fractions. Now, if it's just one fraction in the problem or a fraction in the numerator, fraction in the denominator, just do what we did. Turn it into a division problem and go. But if it's multiple fractions, more than one within, this giant fraction in the numerator or the denominator, or both in this case, I strongly suggest you multiply top and bottom of this fraction by the least common denominator. The LCD, the least common denominator of all the fractions in the entire problem. So if we look at 4, 3, 6, and 12 and say, what is the least common denominator? Your answer should be 12. And what we're going to do is we're going to multiply 12 to the numerator, and we're going to multiply 12 to the denominator. What that's going to do, when I multiply 12 to 3/4, it cancels out the 4. When I multiply 12 to 2/3, it cancels out the 3. And likewise for these denominators in the denominator. The 6 and the 12 will both cancel. So this 12 represents my LCD. So if I take 12 and multiply it to 3/4, literally, 3/4 multiplied to 12 minus 2/3 also multiplied to 12. I'm just literally distributing the 12 is what I'm doing. Over 5, 6 times 12 plus 1/12 times 12. So if we do these multiplication problems here, 3/4 times 12 is 9. 2/3 times 12 is 8. 5/6 times 12 is 10. And 1/12 times 12 is just 1. So your problem becomes 9 minus 8, which is 1, over 10 plus 1 is 12. Whew. That should be our answer. Trying to think what we had for our answer before. Can't remember if it was the same or different. I'm starting to wonder here. But I think we did everything right. Yeah. Did I maybe make that 12 over 12? I think I did accidentally. But this is our final answer. So whatever I wrote on the previous one, that's why I probably shouldn't have done it that way. It's messy. This one is much cleaner. The bottom line is you're multiplying numerator and denominator by that least common denominator, that LCD. And that will clear your complex fraction because in essence, when you multiply by 12 over 12, you're just multiplying your fraction by 1. And multiplying anything by 1 does not change its value. So as long as we do that to the top and the bottom, should be fine. Right? So that kind of leads us to how we handle this complex fraction. Same idea. You look at all your denominators, so x squared, 2x, x, and 4. They're all monomials, so we start with the coefficients of those monomials, the number parts. So we're looking at 1, 2, 1, and 4. So 1, 2, 1, and 4, I would think you would say 4 is my LCD, for the number parts anyway. And we're going to multiply top and bottom of this complex fraction by those numbers, 4. Right? Now the variables. X squared are 2 factors of x, 1 factor of x, 1 factor of x, no factors of x. How many x's would cover them all? 2 factors of x. So 4x squared turns out to be our LCD. And we're going to take 4x squared and multiply it to each and everything in this complex fraction, both numerator and denominator. Now, writing this out, when I distribute this through the numerator, let's write it out over here. I'm going to take 4 over x squared, this first fraction, times this 4x squared. And I'm going to write 4x squared over 1. It'll just be easier. Comparing fractions, and then we have minus 3 over 2x. That also gets multiplied by the LCD, 4x squared over 1. So that's just distributing 4x squared through. I'm just showing this so it'll be easier to cancel out. And there's definitely a lot of canceling that's going to happen. That's the whole point. And we're also going to distribute 4x squared through the denominator. So that'll be 5 over x times 4x squared over 1 minus 3/4 times 4x squared over 1. So the 4x squared, you can see it, I'm writing it as 4x squared over 1, but it's getting multiplied to every single thing in this fraction, both numerator and denominator. And after you do this, there should not be any fractions left over. This looks pretty messy, it looks pretty scary and intimidating, but just take it as 4 separate problems. The x squareds cancel. We get 4 times 4 is 16. Over here, 2 cancels with the 4. X cancels with one of those x's. You get negative 3 times 2x is negative 6x. Numerator. Denominator. One factor of x will cancel out one of those factors of x. So we have 5 times 4x is 20x. And I guess that'll be minus this part. The 4's will cancel. That's it. So negative 3 times x squared is negative 3x to the second. Now, the only thing left to check, this is not a complex fraction anymore. There's no fractions left in this fraction, so that's simplified, but we do have to check to see if anything would cancel here. So we'd have to factor the numerator, which does factor, but I don't think it's going to produce anything. Only 2. 2 factors out, so that leaves us 8 minus 3x. If there's a factor of 2 or an 8 minus 3x in the denominator, we could cancel something out, but sorry, nothing's happening here. So it's 20 minus 3x. Nothing cancels, so this answer here, what I have written, this is good. Don't think that this answer is any better. Nothing canceled, and that's the point of why we factor these, to see if anything cancels. And if nothing cancels, there's really no point to it. Now, not that this is wrong. We can keep this as our answer as well as this one, but we were just checking the factoring to see if anything did cancel. Nothing did. So that's the idea with these complex fractions. Multiply top and bottom by the LCD, and you shouldn't have any fractions any longer. If you still have fractions after that, you didn't multiply by the LCD or you didn't do it correctly. All right.